In this video, we are going to discuss about the total synthesis of Reserpine, right? So in last class we saw the structure of Reserpine, and this is it, right? So let us see how we are going to synthesize this Reserpine, right? So for our syllabus, there is no much thing to know, right? So they directly took one intermediate. From that they synthesized it, right? So we will study this, and these were the rings A, B, C, D and E, right? So let us synthesize this Reserpine, right? So starting material, right? So we saw that one of the name was, we use the same reagent we will use here also, Vibrine, right? Vibrine synthesize, we took this tryptamine, right? The same compound we will take, because see, however, if you see this retrosynthesis, we can take this compound, right? So see, so the starting material was this thing, tryptamine, which we synthesized OCH3, right? So this was the tryptamine, and it is CH2 and NH2, right? So this was tryptamine, which they took. Along with that, they added this reagent, right? So this compound, we call it as intermediate now. See, this has got aldehyde group, other things OCO CH3, right? And here OCH3, right? And here ester COO CH3. You can write COO CH3 or Me also if you write. This is well and good. CH2 COO Me, right? So these were the compound they took, right? So if you see this ring is nothing but A, B, two rings, and that one is ring E. Now we have to synthesize this C and D ring, because A, B, E is there, C, D and E, we have to form those rings, right? That we are going to do, right? And this intermediate, they didn't get this we won't get as a starting material only. This they synthesized by doing 15 steps. After 15 steps, after doing 15 steps of reaction, they got this product. So this product we call it as intermediate for the synthesis of this Reserpine, right? So this intermediate they treated with this tyloporine, right? The name is the same thing, right? Not tyloporine, this tryptamine. So tryptamine and this intermediate, they reacted. Let us see how the reaction happens, everything that we shall see now. Okay. So if you react this thing, so here what happens, NH2 double bond O is there, condensation. If you remove water molecule, you will get N double bond C. There will be loss of water molecule, right? So this will be the reaction, and it is here NH is there, no doubt, NH, OCH3, right? Other things, let it remain like that only. So CH2 N. Now we have double bond C, that C, right? Double bond C. Next to that there is a ring, as it is. Here we have OCO CH3, and here OCH3, and here we have COOMe, alright, and here we have again CH2 COOMe, right? So these were the reaction which we got from those compounds, right? Further, right? So further what they did, so solvent during this reaction, the solvent which they used was benzene at low temperature. Solvent was benzene and reaction was happening at lower temperature, right? And they got easily this product, right? In which this NH2 and CO water molecule condensation happened, that is loss of water, and we got N double bond C, formation of that bond happened, right? Further to this first step they added reducing agent, that is sodium borohydride NaBH4, in which it will convert that double bond into like this NH here, and here it will form CH2. So first step is over. I have written directly the product here. And the second reaction, they heated it in presence of same oxygen was there, everything, and they got this product. After all these two reactions, I am not going to write all those things here, I will write directly here only. So after that NaBH4 and heating in presence of air, they got this amide, right? They got this amide here, amide they got with ring cyclization, right? So 1 2 3 4 5 membered ring formation here it happened, right? So see, in presence of heating condition, this proton fluorine negative charge will come. So here 1 2 3 4 5, right? Like that the ring formation has happened, and they got this product. Directly they have given the product. Let me write it. So after that reaction we got this product. This is ring A, right? OCH3, and this is ring B, right? And here CH2 M, and here ring formation happened, and that ring was cyclic ring, and it has got amide, right? So cyclic amide it is there, and here we got this kind of ring which was present before only, right? So it is OMe, and here it was OMe, and here it was OAC, right? And this is the ring D, and this is ring A, and this is ring B, which is aromatic now, right? So other things are as it is. E, so this is ring E. Now AB, only ring C formation is the thing now, right? So other things are as it is only. So ring formation C, to form this ring, these reactions we have seen it, right? One of the above reaction only in while discussing this Reserpine only we have seen. In presence of POCl3, if you do reaction, this phosphor will have more affinity to this oxygen, so it will be like POCl and other Cl2. As soon as it's lone pair, it will attack here, this chlorine will leave the system, so this oxygen gets positive charge, so it takes this pi bond, this carbon gets positive charge, so this will give its electron density, so positive charge comes here now, right? So like this there will be a ring formation, alright? So these things you know. If you feel I am little fast, you can just see, right? NH, and here it is NH, and here it is aromatic OCH3, no problem, and it is to be like this, right? And here it is OAC, and it is OMe, and it is COOMe, right? So this is the thing, and here this oxygen is there, right, which is there on this carbon. This oxygen is now attached to PO, Cl and Cl, right? And rearomatization is the drawing force. So this electron density, it will be taken here, this positive charge becomes neutral, and it forms double bond, and this H will move as H plus, right? After all this rearomatization, we are end up with this, right? Further, here this nitrogen is there, right? So nitrogen will have lone pairs, so this phosphor oxygen affinity is very high, so phosphor will take this oxygen like this, and this gets positive charge, that will be stabilized by this lone pair of nitrogen, right? Let me write here only. So what we will get? So we will get a double bond here like this, and nitrogen gets positive charge, and here there will be P double bond O minus Cl and Cl. This compound will get as soon as it takes that oxygen O minus, right? Like that, right? And here one Cl will be there, we can show like Cl minus H plus HCl also, you can show it, right? But here they won't stop it here only, right? So what they do, they will remove this double bond, right? And also they will do hydrolysis, right? So let me show it. Yeah, Yes. Are you getting? So what they do hydrolysis. In which it converts this esters COOMe into COOH, acid hydrolysis, and this OAC is there, right? If you do this hydrolysis, it becomes OH. Can I write it here only? I will remove this, and here they will add the reducing agent and heating condition, and the hydrogens comes into like this, and this nitrogen gets its lone pair back, and here we will get COOH, and here we will get OH, right? After all this hydrolysis and heating condition, we got this product, right? So this is the thing which this product we got, right? Further what happens, let me tell it, right? But we required this hydrogen should be above, so isomerization they will do. So just heating condition, some reaction it will happen at thermodynamic condition, and we will get the above hydrogen. This product we will get benzene ring as it is here, right? After this thermodynamic condition, this hydrogen came above, isomerization we can call, and other things, acid will remain acid, this OH will remain as OH, and this OMe will remain as OMe. And this is what? This is nothing but the structure of my what? It is nothing but the structure of my Reserpate, right? So this is our Reserpine, or sorry, Reserpic acid we can call. Reserpic acid. To this, however, if I add some group here, right, and here if I could add methanol, right, so the reaction is like this. So they will add this thing, COCl, benzene ring, para position OCH3, OCH3, OCH3. So here the reaction happens, and directly can I write the product? The chlorine will leave the system, and there is bond formation between oxygen and that. So let me write it here. So it is like see, it will be like OCH3, OCH3 and OCH3, right? Sorry, here it will be COO, OCH3, OCH3 and OCH3. Para to that adjacent, right? And here they will add methanol and they will heat, right? So if they add methanol and they will heat, we will get ester here. So this is one ester, this is one ester, this is OCH3, one OCH3, three OCH3, four OCH3, and this one OCH3. Total 5 OCH3, and this is the ring, and this is above. And the stereochemistry, if you see, these things will be above and this will be below. So this is nothing but the Reserpine. So this is the class where we synthesize the Reserpine, right? So this is nothing but they synthesize this Reserpine, right? So in this video, this is the end of this Reserpine, right? In next class, let us see few more alkaloids. Till then, take care and have a great day.